Okay, this is a Yamaha P2200 or 2201. This is the model without the VU meters, which I would really love, but you get what you get, right? So this is it's awesome. It's working. It does have a bit of a hum on both channels. The right channel is I think it's the right is a little worse than the left. We're going to do both anyway. What I want to do is replace all the capacitors on the circuit board on both channels. It is pretty old. It's getting, I don't know, up 25 years probably. 20 years. So time for a recap. It does have a bit of a DC offset, which I'll show you. I'm going to put the oscilloscope on this guy. Both channels are down at the bottom, as low as they'll go. There's no load on it, but I don't think it's an issue. And we'll fire this baby on. And then we'll attach the ground connection and reset this to ground here, and then check this back. So if we look real close, it says it's got a V average, which I think is the DC offset of 28 millivolts positive. It's a 60 hertz cycle hum coming through there. The peak to peak averaging around 15 millivolts there. I'll get you a closer look here. Amp settles in a little bit when you turn it on. It started out at about 30 millivolts and now it's down to about 12 or 13. It sort of settles in, I think, around 16 millivolts. So I like to, just going to hold it by the resistor here. I like to sort of measure it as it drains, and I think it's probably pretty drained already. It tends to go down pretty quick. It's already at a volt, less than a volt. These two, when it's on, it jumps up to about 80, but within about I don't know, 20 seconds it goes down quite a bit, pretty fast. So, you know, we're down less than a volt, so it's pretty safe. To get into this thing, it's pretty easy. There is some screws on the side here, 1, 2, 3, and 4 that hold it to the actual frame of the chassis. And then this big heat sink, there's some of these, where are those things? Here they are, here's one of them. So it's this sort of cover that covers up the output transistors on each channel. And it just covers up like that. So you got to remove those two things to get into the unit. And then this thing is actually super awesome to work on. All you got to do is just take this whole heat sink and just lift it up. Careful not to pull any wires, but they give you plenty of space. Sort of lift them up, and you can kind of set it right there on the top of it. Make sure it's nice and stable. So there's the circuit board. So what I want to do is actually replace, I have replacement capacitors for, here they are, for all of these orange ones, and then 2 transistors labeled 1 and 2, and those I believe have to be matched as far as their amplification level, HFE level. So I have I bought replacement transistors for those 2, so I might actually just try it, see if I can carefully like sort of desolder them from the board and put new ones on that are really closely matched, and see if that improves the DC offset. I know it's not too bad with the offset, but I'm in here anyway, you know, and I have them, so let's do it. And then eventually what I want to do with this thing, because it has no speaker protection on it, is I bought this speaker protection circuit with 2 big relays. I think I got it on eBay. And I was going to try to attach it to the back side here. It runs on 12 volt DC. this cap is measuring 231 UF, and it's rated for 220, so it's still pretty good. We'll just test them as we go, out of curiosity. There you go. New capacitors and new transistors right there. So while I was in here, I was just going to clean up the ground connections on these XLR jacks. I just got some sandpaper, so I'm just going to shine them up a bit. We'll put this side back together and we'll start working on the other side. Measure the millivolts coming off this thing, which would be 12 millivolts. It's better. Let's hook up the... I'll have to compare the two, but it seems like it's better. It's still got some 60 cycle hum coming through it. Peak to peak was around 40 millivolts, now it's around 12. So that's an improvement. Nice, I'm happy about that. Peak to peak is around 28, 19, 20, 20. That's the right channel. Not quite as bad as the left, it seems like. Still a bit of DC offset, but it's not, again, it's not bad. Like anything under 100 millivolts is okay. Oh my god! Okay, so here's the right, or the, sorry, channel A, that's the left channel. Keep getting those mixed up. So here's channel A with the new capacitors and new transistors. These two right here, right in the center. It went a lot smoother on this side, because I'd done it already, and then I cleaned up the ground connection right in there. And here's the oscilloscope connected to the right channel here, so looks like about a DC offset about 12 millivolts and about 12 millivolts of 60 hertz cycle coming through. So I don't know. It's an improvement. I mean, it was better. It's better than what it was. Okay, so here's the Yamaha P2200. I've replaced the capacitors on it and the two differential transistors, and I've mounted this speaker protection circuit on the back of it, because this amp doesn't have speaker protection actually. Like, so if it ends up failing or one of the transistors shorts out, the output transistors on the side here, if it shorts out, it's going to dump 80 volts across the speaker outputs and potentially blow some speakers. So this is a protection circuit. It's a couple relays and an IC chip that when the IC chip detects DC current, it pulls the resistors off, breaks the connection. So I've just got a 9-volt battery here, and I just going to touch the one of the speaker inputs to it and see if it kicks out here. So it kicked out and then it went away. It sort of reset itself. And both channels work. It's pretty slick actually. I don't know that it'll handle 80 volts, but it's what I got. So peace of mind, sort of. Okay, so here's it all wired up. I'm going to clean it up a little bit, but so the speaker outputs from the amplifier are going to the inputs of the protection circuit board, both of them on the inputs, and then the power is connected to it. And I've got one just sort of test speaker over here that I've got connected to channel B here, the right channel. And it seems to work. There you go, pretty happy about that. Alright, so one more problem with this thing. I just kind of was fooling around with it after I replaced everything and found out that the attenuators on the front did absolutely nothing. There was no attenuation at all. It was just sort of full blown and that's it. So just in closer inspection, somebody here, I left this one the way it was. Somebody had removed the two wires. One wire comes from the input, it goes to that, and then the wiper goes to the driver board, and they just soldered the two wires together, so it's just, there was no attenuation at all. The thing was still grounded. They left the ground, but and both of them were done the same way. So I think what was going on probably is the attenuators were probably dirty and cutting out, and so they just removed them completely from the circuit. So I've taken the attenuator, the one attenuator, and the model number for these things, it's a Yamaha, again it's a Yamaha P2201. The only difference is it doesn't have the meters. And this is the attenuator. It's made by Alps. It's a Japanese company. It's a 253Y, and it's a 33K kilo ohm resistor, stepped resistor. And I've taken it and kind of taken the attenuator apart. You can see right here, and inside here you can kind of see, get a good view of it. There's the little wipers that sort of press down against the circuit board there, and those looked fine, but it was quite dirty. So I've sprayed some electronic cleaner and did some testing, and it seems to be okay. So no short connections or anything like that or whatever, so we'll put it back together, and I'll do the same with the other one and see if we can wire it back up properly again, and hopefully that'll fix it. I'm going to make sort of double sure that this is nice and clean here before I do that. Removed both switches and took them completely apart and wiped down, took some electronic cleaner and wiped down the tracks and the wipers, and measured them, and they're reacting much better. So they're back in there, brand new, and I've rewired it so it's back up to where it was. Like I said before, the two white wires there and those two white wires there were removed from the pot and just soldered together, so there was no attenuation happening. It was just full volume all the time, and the ground was connected, but that was it. So now they're both back connected to each potentiometer, and I've got it up and running. Let me get some music going. Give it a try. we'll turn it on. It works. All right. Time to pack this thing up and put it back in the rack and connect it up to my good speakers and play around with it, see what we get. That was pretty fun. I like doing that. Lots of work to do on it, but it's vast improvement with the new caps, new differential transistors, cleaned up the grounds, added some speaker protection, and fixed the potentiometers in the front so that they're working again. Pretty awesome. Working pretty good.
You said you wanna stake out your claim high above the city from where you came. Don't you know the
Like before I did all the work on that amp, it would be humming like crazy. It would have a pretty severe like 60 height cycle hum, and yeah, it's pretty awesome now. It's nice and clean, super clean. Pretty happy. There it is in the rack. Back at work.